message type and 7-bit address.
Okay.
We have different types of read and write operations in CCI. 4 types of read operations and 2 types of write operations.
Okay.
First, write operation. Write is 2 types. Single write from the random address, sequential write from the random address.
Okay.
నెక్స్ట్ అంటే దీని గురించి ఎక్స్ప్లెయిన్ చేయాలి
అంటే ఏం చదివారో అది జస్ట్
మనం సింగిల్ రైట్ ఫ్రమ్ ద అది random address in this we directly send one address to write the data.
Okay.
1 minute, sir.
Okay.
Single write from the sequential address.
Okay.
In this we send one address to write the performance.
Okay.
To write the data, then sequential write from the sequential write to the random location. In this we send the address.
Okay.
But it is sequential write, that's why it continuously in write and read mode.
Okay. What is the thing we are using for continuous write and read operation?
Sir?
What is the start repetition condition?
అది ఇది start repetition. We are using start repetition only.
Okay. Yeah, start repetition means
continuous read and write.
Okay.
In read we have 4 types. That is a single read from the random address, single read from sequential read from the random location. Next one is a single read to the current address, single sequential read to the current address. In first single read from the sequential address, we first send the dummy address from the master to this. First we write a dummy address to the slave.
Okay.
After that we send a start repetition condition to read the operations.
Okay. Are you preparing notes, Ramya?
అంటే నేను ఏమనుకుంటున్నా సార్, ఫస్ట్ ఈ సిఎస్ఐ అంతా అయిపోతే ఇప్పుడు మనం ఒక్కొక్క లేయర్ గురించి చెప్పుకుంటున్నాము. ఇప్పుడు రిపీట్ అవుతా ఉంటున్నాయి కదా సార్. సో నేను ఏమనుకుంటున్నా అంటే సిఎస్ఐ మొత్తం అయిపోతే ఆ సిఎస్ఐ గురించి అన్ని పాయింట్స్ ఒకటే దగ్గర రాసేసుకుందాం అనుకుంటున్నా.
ఓకే. ఫైన్.
నేను క్లాస్ వింటున్నా అంతే. సో ఒక ప్రోటోకాల్ అయిపోతే ప్రోటోకాల్ ఏంటి, దాంట్లో ఉన్న పాయింట్స్ ఏంటి, నెక్స్ట్ డిఫరెన్సెస్ ఏంటి, అట్లా రాసుకుందాం అనుకుంటున్నా. ఎందుకంటే ఇప్పుడు రిపీట్ అయిన పాయింట్స్ రిపీట్ అవుతే కన్ఫ్యూజ్ గా అయిపోతుంది, అందుకోసమని.
ఓకే. ఫైన్.
ఎందుకు సార్ అలా అడిగారు?
ఓకే. ఫైన్. Then next, what else you studied?
అంతే. అదే ఇదే చదివా. ఓన్లీ మొన్న ఎస్టర్డే క్లాసే చదివా అంతే.
ఓకే. 5 లేయర్ ఇంకా స్టార్ట్ చేయలేదా?
జస్ట్ కొంచెం చూసా, కాకపోతే పూర్తిగా చూడలేదు, కొంచెమే చూసా. పాప ఏడ్చేసింది. అంటే క్వశ్చన్స్ అడగండి, నాకు వస్తా, నేను చెప్తాను. మీరు అడగండి ఒక 2-3 క్వశ్చన్స్.
వాట్ ఈస్ ద యూజ్ ఆఫ్ 5 లేయర్?
5 అంటే ఓకే ఫిజికల్ లేయర్ కదా. సో 5 అంటే నేను ఓకే కన్ఫ్యూజ్ అయిపోతున్నా.
ఫిజికల్ లేయర్.
ఫిజికల్ లేయర్ యూసేజ్ ఇస్ నథింగ్ బట్ అది వాట్ ఎవర్ వి సెండ్ ద byte information, it is converted into electrical signals.
Okay. What are the different 5 lanes are there?
C5 and D5.
Okay. What is the main difference in between them?
in D5 we have clock lane, data lane, and differential data, and we have only 1 to 4 lanes are there in D5. Next is C5, clock and data lanes are embedded, and we are using trios. In this, we are using one or more lanes.
Okay.
These are the main differences.
Okay. So, what are the transmission requirements related to your D5 lane?
అర్థం కాలేదు సార్ మళ్ళీ ఒకసారి అడగండి.
That means in transmitter side we are using D5 layer, right? Okay. And receiver side also you are using D5 layer. What are the requirements we need to maintain for the D5 layer? What about that data lane module,
Okay.
and then
First,
what about the clock?
clock lane should be high, data
Okay.
lane should be low.
Okay.
Remaining is differential data, it is positive or negative.
Okay. What is the need of D-skew calibration?
D-skew for data alignment.
Okay.
Lane alignment, I think.
Why we need lane alignment?
We send different types of data to different lanes, different types.
Okay.
So one is sent fast, one is sent slow. So to make that in order, we are go for D-skew alignment.
Okay. Fine. And what are the alternative low power states? What is the need of that alternative low power states?
Oh no, sir, I don't know about this.
Alternative low power states, why we are using means, see, some of the lanes are not used, right? Because in data, uneven data we are sending at that time, some lanes are in idle condition. So that lane should be going to the low power states. So that low power states will be operated at the alternative low power states. That means minimum power we need to give, then it will be active. Okay. So that is the use of alternative low power states. So using low voltage, low power,
Low power.
okay, low voltage, low power signals we are using. So for this replaces that whatever the low power states are there, okay, that states will be replaced here. Okay.
ఓకే సార్ నన్ను ఇట్లా క్వశ్చన్స్ టైప్ అడగండి ఆన్సర్స్ చెప్తా నాకు మొత్తం ఎక్స్ప్లెయిన్ చెప్పాలంటే ఏం చెప్పాలో అర్థం కావట్లేదు.
Okay, fine. So then what is the C5 layer in your, what is the main difference between that in transmitting the information from transmitter side to receiver side? So what we are maintaining in the C5 layer? So what are the requirements in the transmitter module and then receiver module?
So once again repeat the question.
So same question. Previously you told that D5 layer, right? Same way C5 layer also we have in the physical layer option, right? C5 is also composed of one or more unidirectional lanes and then clock lane. Okay,
Clock
you
lane,
told,
data lane.
you already explained me the in C5 lane data and clock should be embedded together. So you told that, right? So and then three lanes are used. So trios are used. In the trios means that differential positive lane, differential negative lane is there. Okay, and also positive negative is also there. Then here, the here what is the different thing is, in C5 layer, in D5 layer, ECC will takes place. Okay, while error correcting codes are takes place to find the errors, right? And then here also another thing is there, synchronous word support. What is the use of synchronous word support in C5 layer?
For alignment of data.
Okay. So the synchronous word
Getting
is
data.
inserting in between the data periodically, right? To get the data normally, so without any overlapping, right? So at the receiver side, we are removing that synchronous words, because we need to know what is the boundary of your data. Okay, so to identify the lane boundaries, and then we are deleting that synchronous words, right? And also maintain that symbol alignment because of improving robustness. Okay, so that is
Okay.
the purpose. Here also alternative low power states are also there, right? Okay, so why we are using this alternative low power states means reduces the leakage current and also improves the TMI. Okay, electron migration interference will be improved, and also ESD will be improved. That means electrostatic overseas robustness is also improved, right?
Okay.
So that's what we have explained in the C5 layer. And what is the multi-lane distribution and merging? What is the lane merging and lane distribution? At which
Mm.
state you are using distribution, and at which state you are using merging?
నేను ఇది చూడలేదు సార్.
Okay.
హాఫ్
So
వీడియోనే చూసా.
fine. So lane merging and lane distribution means, so we need to use this transmission side we are using the distribution, and receiving side we are using the
మెర్జింగ్.
merging.
మెర్జింగ్.
Okay. So why we are using the line merging and lane distribution means, so because in each lane we have to transmit number of bytes, right? Each
హ్మ్.
byte having each lane having different bytes of data we are transmitting. Okay, that bytes are distributing sequentially by using round robin
రౌండ్
manner,
రాబిన్
right?
మ్యాన్. హ్మ్.
Round robin manner means line, suppose you are using two lanes, okay, that will be transmitted two data. Okay, in that way we are using, right? So serializer and deserializer are using. Why we are using the serializer and deserializer?
హుహు.
So you can study that. Okay, serializer, deserializer means sequential order. We are sending the serializer at the transmitting side, and then
సో, మన
deserializer.
డాటా అనేది
Uh,
ఒక్క నిమిషం సార్. డాటా అనేది
uh,
ప్యారలల్‌గా ఉంటది కాబట్టి మనము
hmm,
సీరియలైజర్ యూజ్ చేయడం
hmm,
వల్ల డాటా అనేది సీరియల్‌గా సెండ్ అవుతది. అంతేనా?
సో ఆర్డర్‌లో వెళ్తుంది.
అదే.
ఆర్డర్‌లో
ఆర్డర్‌లో
వెళ్ళడానికి
వెళ్తుంది.
ఆర్డర్‌లో పంపించడానికి చూస్తుందన్నమాట సీరియలైజర్. సో
ఓకే.
డీసీరియలైజర్ విల్ బి డిఫరెంట్ ఆర్డర్‌లో మనకి ట్రాన్స్మిటర్ సైడ్ నుంచి రిసీవర్ సైడ్‌కి వెళ్తుంది. ఓకే. సో
ఓకే.
that will be deserialized at the receiving side. So that need to be reconstruct our original image, right? So
హ్మ్.
for that purpose we are using deserializer at the receiver side.
ఓకే.
Okay, so I'm sharing my screen.
ఫస్ట్ రోజు అసలు కన్‌ఫ్యూజింగ్‌గా ఉండే. సెకండ్ రోజు కొంచెం క్లియర్ వచ్చింది.
Hmm.
థర్డ్ రోజు ఈ రోజు
Hmm.
కొంచెం ఓకే.
Clarity.
కొంచెం
Yeah.
క్లారిటీ. ఫస్ట్ మీరు అన్నీ
Hmm.
చెప్పారుగా. ఇన్ని
Uh,
రీడ్ ఆపరేషన్స్, ఇన్ని రైట్ ఆపరేషన్ ఏం
Preparations.
గుర్తుంటుందని భయమేసింది నాకు
Hmm.
చూసి.
Hmm.
ఓకే. ఏం లేదు జస్ట్ చిన్న చేంజెస్.
చిన్న కాన్సెప్టే, బట్
హ్మ్.
we need to understand what it
ఓకే.
happens.
హ్మ్.
That is the main difference. Okay, so
హ్మ్.
my screen
కాకపోతే
is.
ఎక్స్‌ప్లెయిన్
Hmm.
చేయనీకే సరిగ్గా రావట్లేదు నాకు.
No
ప్రాక్టీస్
problem. So
చేసుకోవాలి.
listen, and then practice more, study more, and then you will get more interest. And also, you are explaining to me, right? So maximum data you are explaining, because see, this is not a rocket science, right?
హ్మ్.
So
అవును.
even rocket science is, see, our laptops are same, our mobiles are same. So even though we are changing, but mobiles are also updating. What we are updating? Camera is updating, our
హ్మ్.
storage is updating, or
హ్మ్.
processor is updating, or
హ్మ్.
some battery is updating. Okay, so
హ్మ్.
these are the updates only, but
హ్మ్.
calling improvement is same. Sometimes we are using internet calling, sometimes we are using normal call, sometimes we are using WhatsApp call. Okay, sometimes we are implementing some other apps to call.
హ్మ్.
Okay, so here Google Meet or Zoom Meet or LMS we are using. That's
హ్మ్.
what that's what the changes only happening means. Nothing will be changing. So that means our whatever the previous subjects are there, all the subjects are same.
హ్మ్.
See, main difference, your BTech is passed out at 2017, right?
హ్మ్.
Even 25 passed out are also studying the same syllabus.
హ్మ్.
Then what is the changing here? The same subject we need to study more. That's all. That's the main motto. Okay, what you are seeing now screen. lane distribution already completed, right? And then multiple interoperability, and then skew, deskew, that means alignmenting of data. Up to this, you need to study. Okay. So then, low level protocol we will discuss today. So screen is big, right?
Oh, sure.
What you are seeing now. Okay, fine.
1 minute, sir.
Okay, okay.
Okay, sir.
Hmm. So we are today. Yesterday we have discussed about file layer, and then in that lane management, how the lane management will be distributing at the transmitting side and then receiving side. After that, lane interoperability, skew and deskew. So why we are using skew and deskew, and then serializer and deserializer, all these things. So because we are sending the transmission data from transmitter side to receiver side by using C5 layer and D5 layer. So C5 is transmitting the data within the clock, and then both our clock and data should be embedded here. Okay, and then D5 layer that clock
Hello.
line is separate. Yeah.
Cut అయిపోతుంది.
Okay. So just inform me. So whenever my voice is not reaching you. Okay. So fine. Now today we will discuss about low level protocol layer. Okay, what is that low level protocol layer? What is the use of low level protocol layer? So suppose low level protocol means, imagine if two people are communicating each other. So about some parcel.
బేసిక్
Okay,
యూజ్ సింక్రనైజ్ చేయడానికి మనం లో లెవెల్ ప్రోటోకాల్ యూజ్ చేస్తాం.
yeah,
కరెక్ట్.
so we need to synchronize the data. For that purpose, we are using the
లో
low level protocol layer. See, in this low level protocol layer, suppose just think about, I want to send a gift for you. Okay, so then I am thinking in my mind. So what I need to send, or what is your how do you identify that, and then what type of data you are getting, and then how you're reaching, so and then how I need to know. Okay, all these things we are thinking, right? Suppose
స్టార్ట్
and
స్టార్ట్ ఆఫ్
uh,
ఆపరేషన్, ఎండ్ ఆఫ్ ఆపరేషన్ అండ్
yeah,
సింక్రనైజేషన్ అని.
yeah. So we need a start signal, and then label for identification. So what is the data we are sending? So label is needed, and then payload, what type of data we are sending, and then also we need to detect the error, right? So what type of error you are getting that. So that things we need to remember. So for that purpose, we are using low level protocol layer. So in this low level protocol, what I am telling, that identification, and then starting signal. That means starting signal means there is a packet structure. Okay, there is a packet structure, either short packet or long packet structure. Okay, so we are using packet structure. In this packet structure, we are having packet header and packet footer. Okay, packet header is that where we are starting the data, and then packet footer where we are ending the data. In between that, payload will be transmitting, that is the data 0 and data 1. See here, total 4 bytes of data we are transferring. Okay, that's what that low level protocol is doing here. So basically, what we are doing, that low level protocol means we are sending the data, okay, from the transmitting side to receiving side by byte. Okay, so one byte is transmitting, that means byte one we are transmitting, after that byte two we are transmitting, and then byte by byte we are transmitting the data, right? So each data, that is the data 0
1 minute సార్,
data.
1 minute సార్.
Yeah,
పాజ్
yeah, yeah.
చేయొచ్చు.
Okay, okay, fine.
సారీ సార్. రోజు మిమ్మల్ని డిస్టర్బ్ చేయడం అవుతుంది.
No problem, Ramya. No problem.
వాళ్ళ ఫ్రెండ్స్ ఇప్పుడే ఆడుకోవట్లేదంట.
Okay, okay. Fine. How old how old your child?
3 ఇయర్స్ సార్.
Sorry,
3
3 years.
సంవత్సరాలు.
3 years. Okay, okay. 3 years is not a problem for you. I think this time is crucial for you. Maybe. Mm, yeah.
ఆడుకోవట్లేదంట.
Mm, yeah, yeah. Okay. So here, what is LLP means? LLP means that means we are communicating, right?
స్క్రీన్
Uh,
చిన్నగా
screen is not.
ఉంది.
Yeah. So LLP means we are communicating, right? So we are communicating means different data we are transferring. Okay, how we are transferring the data means byte by byte. Okay, so for that we need to think about what type of data we are sending. We don't know about it. So I need to send the packet for you. Okay, from the transmitting side to receiving side. Okay, so inside that, what type of data is there? I don't care about that because that data may be either packet data, so image or video, and then some raw data or any type of data we are sending. Because transportation data means either metadata we are sending or compressed video sending. Okay, any video or video we can send or image we are sending.
కట్
Okay,
అయిపోయింది
or
సార్ ఇప్పటిదాకా.
JPEG form. Yeah, JP. Ah, so video we are sending or image we are sending or any metadata we are sending, right? From the transmitting side to receiving side. Okay. Hello.
ఓకే సార్.
Uh, so then here what I need to identify here is so that data transmission we need to think about the arbitrary data. So arbitrary data means what type of data we are sending. That means it supports arbitrary data or raw image. Okay, raw data we are sending or RGB data we are sending or YUV data we are sending. Okay, this different data types we are transferring from the transmitting side to receiving side. Okay, so in this data, so what how we are sending the data means in the packets format we are sending. That is the short packet method and then long packet method. Okay, short packet method means only one or two data are supporting here. Okay, and then long packet data method means multiple data we are transferring. That means in the packet header, in between the packet header and packet footer, we are sending the payload. That payload is n number of data bytes we are transferring.
ఓకే.
Okay, so here the total length is 6 bytes of data we are transferring. That means uh, 6 bytes and 2 bytes for packet footer and packet header. Okay, so that means total 8 bytes of data we are transferring here. Okay, include that it is also checksum we are including. That means error detection codes are also improving. That is ECC data and then CRC data. So ECC for D file layer and CRC for C file layer, we are using that. Okay, and also checksum means
సిఆర్‌సి అనేది
checksum is yeah
సిఆర్‌సి అనేది
cyclic
మనకి కోడ్ డిటెక్షన్ కోడ్ కరెక్షన్
cy-
గదా! సైక్లిక్ రిడక్షన్ చెక్
yeah
చెక్ ఓకే.
code correction purpose. Yeah, code correction. That is cyclic redundancy
చెక్.
check we are using. Okay, cyclic redundancy check we are using. Okay, so that is basically used in C file layer, and then ECC
ఈసీసీ.
error correcting code. Okay, that is used in D file layer. Okay, error correcting codes. Okay. Huh. So I told you what is the data we are transferring, and then and we have uh, different data bits like hardware and then serialization and decoding. All these things we are having, right? So how we are sending the data means different packets are sending packet 0, packet 1. So in this way, different virtual based on the different virtual IDs, we are sending the data. That is the virtual channel supports. And then here, uh, how the low level protocol data we are sending means in the short packet method, long packet method, long packet method, and short packet method. In this way, we are sending the data. Short packet,
Okay.
long packet, followed by the long packet, and then how many long packets we are having, so those many data we are transferring. After that short packet, we are transferring that. Okay. So why we are using these long packet, short packet method means we need to send different type of data. For that purpose, we are using the short packet and long packet methods. And then
అంటే
we have,
అంటే మనం
hmm,
ఇమేజ్ ప్లస్ వీడియో అట్లా పంపచ్చా సార్?
yeah, image, video, or JPG format, and then metadata or compressed image. Okay, all these things we are sending. Okay, so any type of data we are sending. That payload may be either image or JPG format or data or compressed video. Any type of data we are transferring. So that is the main usage of this low level protocol layer. Okay, so this low level protocol layer don't see what type of data we are having. Okay, that will be sending. That is the main role. See how the courier boy is sending the information. So you are ordering something. Then he is picking your order and then sending to what is his duty means he need to deliver the order to you. Okay, so he doesn't want what type of information there in the covered box, right? So your mobile, you're ordering some mobile, or you're ordering some jewelry, or any type of things you are ordering, right? So in that way, I'm checking here. Low level protocol will be sending the data. Okay. See, LLP
కట్ అవుతుంది సార్ వాయిస్.
supports that multiple interleaved virtual channel. Yeah.
కట్ అయిపోయింది
Is that
టోటల్
clear
ఎల్ఎల్పి.
now?
ఆ!
Okay. Now,
ఓకే సార్.
uh,
కాకపోతే చెప్తుంటే అంత క్లియర్‌గొస్తుంది. ఒక్కొక్కసారి ఒక ఒక 10 సెకండ్స్, 15 సెకండ్స్ కట్ అయిపోతుంది. చాలా సార్లు నిన్న
oh,
కూడా అట్లానే అయింది.
okay, okay, fine. So just tell me whenever my voice is breaking, right? Okay. I will stop that, and then we will continue from where we are stuck at that previous data. Okay. Fine.
ఓకే సార్.
Fine. Okay. So now um, we have a virtual channel support. What is the use of virtual channels means? See, virtual channels LLP supports that multiple interleaved virtual channels, because we are sending multiple datas, multiple bytes on the same lanes, right? In the same lanes, we are sending lane 1, lane 2, lane 3. On the same lanes, we are sending multiple datas, right? So for that, we need to support multiple streams on the same physical layer. We have a virtual channels. Okay, these virtual channels, because we are receiving the data from front camera, okay, front camera or rear camera, or depth sensors, or some hardware high definition related information, all these things are receiving, right? So all these are carried by the virtual channels. Okay, and then some packet header and then packet footer. So why we are using synchronized packet means, so synchronized packets are always used to identify where we are starting the frame. Our frame is starting where we are starting the frame, and where we are ending the frame. Okay, frame start, and then frame where we are ending, and then how the line is starting. Okay, line start, and then line end. All these things are synchronized with the packetized formats. Okay, so some special synchronization packets are using at that time all the frames will be transmitting, or some image lines are transmitting. Okay, so image lines are transmitting. Similarly, some video timings are transmitting. That's why we are using this payload concepts, all these things. Okay, are specialized packets format. In this specialized packet formats, we have data identifiers, word counts, and then ECCs. Okay, so what are the ECCs means? 6-bit error correction code is there for bytes from 0 to 2 bytes. We are data transferring from D5 layer. So in that, any data is missing or any data is correcting or corrupted, that data we need to identify. So why I should need this means, because we are transferring more data from the cameras. Okay, because cameras are sending more images, and then we need to identify small noise is there means your data may be corrupted. Your data may be corrupted. Okay, that means you lost the data. Okay, same thing that will be happen here. And then payload types, payload size and payload formats we are having. For that we are using the checksums. Okay, so 16-bit checksum we are using. That 16-bit checksum is used for detecting the error. That error should be in the payload. Okay, so ECC is that your error should be in payload. Okay, so error is there in payload or not. Okay, CRC is used to identify that your error is there in header or not. Okay, packet header or not. So that will be identify that. Okay, so CRC will be identify that your payload having the errors, and ECC will identify that your packet header correcting that. Okay, where the error is having in your header, is that error is having or not. See, ECC is that is identifying that is a 6-bit ECC. So calculated for header bytes. What are the header bytes we are transferring? That header bytes having any error or not? For that purpose, we are using the ECC. Are you understood?
sir.
Okay, fine. So short packet method, long packet method, we know, right? So how the data will be transmitted, and then this will be same thing we are explaining here. This is the short packet method, and this is the long packet method. If you are sending 2 bytes of data, we are using the short packet. More than 2 bytes of data, we are using the long packet methods. So the structure of the long packet method followed by the packet start of transmission, packet header and number of data, packet footer, and end of transmission. And same way, short packet method, low power states are there. Low power states, start of transmission. So this low power states entire packet we are having. So that LPS is that followed by, see, LPS, short packet, long packet, long packet, and so on. So again short packet and then LPS. This is the format we are sending the data from the transmitting side to receiving side. So this data packet header, what type of data we are having? So that is having 32-bit data we are having. 32-bit data means 4 bytes of data we are transferring. That is the packet header. Okay, so and then header, what are the fields are there? I told you that header fields, what are the header fields we are having? Data
Virtual.
identifier,
But
data identifier, word count, and then ECC. All these things are having. And then virtual channels are also we are having the packet header. Okay, so that data loads. Okay, and then here also we are using different data types. That data types I told you that. Okay, raw data type we are using, and
why?
then
Happy.
RGB DV data
Why
and
you?
YUV data you are transferring, right? In this way we are transferring the data. Okay, so that payload will tells you exactly how many data bytes you are transferring from transmitting side to receiving side. Okay.
Hmm.
Hmm. So why we are using virtual channels means because we are receiving the data from front camera, rear camera, and then depth sensors, all these things we are receiving the data, right? For that purpose, we are using the virtual channels. Okay. So this is the low level protocol layer. In this low level protocol layer, we are having different type of long packet structures for D5 layer and then C5 layer. Okay. So both the layers we are using. Same thing you can imagine here also. You are sending the large parcel of data. Okay, long packet structure we are using. That long packet structure, why we go for the long packet structure means more data we are transferring from the transmitting side to receiving side. So that long packet structure, how we are sending the data from transmitting side to receiving side, we are sending either image, the large image, HD image you are sending, that means large image, or video data you are sending. Okay, large image, large video data we are sending by using, how we are sending, by using either D5 or C5 layer. Okay, so these five layers are used to transmit the data from camera to
Processor.
processor. Okay, so that is the long packet format. How we are developing the long packet data means, so first, uh, whatever the image data we are having, raw data or RGB data or some YUV data or JPEG, JPEG. Okay, so these data we are transferring, that complete flow, what we are having, low power states, and then start of transmission. In that, header is there, packet header. In this packet header, 32 bits are transferring. Different packet header identifiers are there, right? Here also same thing will be followed. Data ID. So this data ID contains two virtual channels. These virtual channels are supporting for different cameras images capturing purpose. After that, word count is there. So this word count is the 16-bit count. So 16-bit count means it will carries that multiple datas. And also we are having some what it called VCX. That means what type of data we are sending. So I told you that start of transmission. That means what real data you are sending. Okay, so start of transmitting means your real data you are transferring, right? So that is the wake up call. That is the start of transmission. From
Okay.
low power state modes to you are sending the data from high speed mode, right? So that five layer is switching. Whatever the low power states we are having, and then start of transmission, this will be switching. Okay, that is the indication of start of packet generation. Okay, and then packet header we are having packet identity, payload, and error correcting codes. Okay, so D5 layer we are using, that is 32-bit data. That means 4 bytes of data you are transferring, right? In this data identification is 8 bits, and then word count is 16 bit,
1 2 bytes.
and then VCC, that means virtual channel is having VCX as well as error correcting code. Error correcting code also there. Okay, that is total 8 bits. What is the use of data identifier means what type of data you are transferring, right?
అంటే
So
RGB ఇది కదా.
yeah, what type of data? So we are having different data types. That is will be taking care of that. And then we know that virtual channels. What is the use of virtual channels? We are streaming the different packets, right? Because we are receiving the data from packet header and packet footer. Okay, all these things we are receiving the data. So that is the purpose we are going for virtual channels, right? In this virtual channel, VC0 and then VC1, three virtual channels are there. Okay, that is VC. Okay, in this VC0, VC1, and VC2, three virtual channels are there. So one for front camera, other for rear camera, and other for depth sensors purpose we are using. And then we know that so data types, how we are transferring the data. And then word count. What is the use of word count? It tells that payload size, whatever the payload we are having. Okay, so that payload is having 16 bits. Okay, 2 bytes of data we are transferring. That means so 16 bits means what is the capability we are transferring the data. 2 power 16, right? 2 power 16 means, so that is huge data. 2 power 10 means 1024.
1024.
Okay, 1024, and 2 power 11 means 2048. Okay, 2048, and then 2 power 11, and then 5 bits of data to remaining. What is the
Double.
value? So 2 power 5 is there. 2 power 5 means 32 bit. Okay, so that means 32 bit payload data we are sending. Okay, so 32 into 1024, sorry, 204 data we are
48.
transferring. Okay, that is the word count. Okay, if suppose if your receiver is not receiving that much of data, means we need to think about the virtual channels. Okay, that virtual channels will take care of that, and then it will be sending the data. Okay, and then ECC, what is the ECC capability here? ECC capability, it will correct either single bit error, okay, or then it will also detect that double bit errors. Okay, so single bit or double bit errors, it will be correcting that. Okay, so this ECC will be taking care of that, your payload header. Okay, header only it will take care of that. Okay, they will ask you why header is corrupting is dangerous, means, so your receiver data may be wrong, because your header may be wrong, means your receiver also receiving that error data, right? So that is the main thing we are having. Okay, that is the long packet data we are having. And then packet data means, this is the packet data. In this packet data, data 0, data 1, data 2, data 3, and so on, so n number of data we are transferring. Okay, so then depends upon the word count, equally distributing the number of packets, right? There is no restriction. Okay, the data counts, what, how many data bytes you are having, those many data are transferring in the packet data. Okay, that is the payload. Okay, and then you have CRC. Okay, that is checksum, cyclic redundancy check, that is a 16 bit, right? So 16 bit data we are having. That 16 bit data, how it is computes the data means, how it checks that means, it computes the data, that means it calculates that. Okay, it calculates the data, depends upon the some equation they are giving, x power 16 plus x power 5 plus x power 2 plus x power 0. In this way they will give the some polynomial, and then so appending some data. Okay, depends upon the data, we are appending some 1000 or 4 zeros you are adding, or 5 zeros you are adding. So depends upon the data we are appending. Okay, some data will be appending in the checksum region. Okay, so that checksum will be identify that is there any payload is corrected. Okay, ECC will identify that header is there any error. Okay, that is ECC will take care
ఈ
of that.
ప్రాసెస్ మనకు రావాలా? ఈ సీఆర్‌సీ మనం ఎట్లా చెక్ చేస్తామనేది మనకు రావాలా?
Yeah, we need
ఐ
to
నో
know.
దట్ ఇన్
We need to,
ఎడ్యుకేషన్.
yeah, we need to know that how we are identifying the CRC.
We have
So
parity bits and data bits.
yeah, in your BTech time, computer networks are there, right? That such
In communication subject only we have this. I know the process CRC.
yeah. So that process we need to learn. Okay,
Okay.
fine. Same thing. So this is the long packet data, so it's D5 layer, and same thing will be explained for the C5 long packet data. See, end of transmission, you know that end of transmission means, so that packet is transmission is finished. That means whatever the packet you are transmitting from transmitter side to receiver side, it is finished, and then again it is moving to LPS, low power states. That means lanes are returned to LPS state, means your power should be saved. Okay, so that is the main format we are explaining here. And the same thing, and then long packet format, how we are getting the data means, long packet data in the C5 layer, same thing, long pack LPS, that means low power states and start of transmission, it is moving from low power states to that beginning of the data transmission. After that, packet header. In that, what are the things we are having? Same D5 layer and C5 layer, both are same, but here the formula will be 6n into 16 bits. That n represents that how many C5 layers we are using. Okay, how many C5 layers we are using, that tells about this n. Okay, that means a number of C5 layers. That means n copies, n copies, n copies we are transferring. Okay, so this large header, whatever the large header we are using, because n number of lanes we are using, that n number of layers we are having virtual channels and then data types. Okay, data types are 6 bits and then virtual channels are 2 bits. Okay, and then we are having rec, that means res, reserved bits, and then virtual channel extension, vcx means virtual channel extension. Okay, so these two lines are there in that first byte. After that, second byte, data identifiers. I told you data identifiers means raw data or crc, sorry, raw data, yuv model, rgb model, all these things. And then word counts, you know that word count means what type of data you are sending. And then crc, cyclic redundancy check. So that errors in c5 layer we are using, in payload header we are using crc. Okay, so in d5 layer in header we are using ecc. Okay. Hmm. So CRC, what it calls that instead of ECC, we are using, so that means in the C5 layer, we are sending large data. If you are sending small data means we will use the ECC. Okay, if you are sending large data means we are using CRC techniques. Okay, yeah, CRC techniques will be used. So because here multi-lane trios are used, right? In C5 layer, trios are used. Okay, these trios will be having large number of data. That means multiple bytes are transferring, because it is encoding the clock, right? Okay, the clock is encoded here. So that is the reason we are using C5 lane in that. See how we are how we are transferring the data from transmitting side to receiving side. Same thing will be there here also. Packet data, data 1, data 2, and also packet footer in this crc. See, packet footer also we are having crc technique only. And then some filters we are using. So filler bytes, what is the use of filler bytes means lane alignments, how we are aligning the lanes. Okay, so lane 0, lane 1, so that alignment will be taken care by this filler bytes. Okay, yeah. After that, end of transmission and lps state. So all
అంటే
these things.
మనకి ఒక్కొక్క
Hmm.
లేయర్ లో అట్లా డాటాను
Hmm.
అలైన్‌మెంట్ చేసేదాన్ని ఒక్కొక్క నేమ్ తో అంటే ఇప్పుడు
Hmm.
డీసీపీ కూడా అలాంటిదే కదా సార్.
DSQ
సో
code,
అది ఆ లేయర్ లో
DSQ also
డీసీపీ
same. Yeah, DSQ also same way we are using filler bytes. So
బట్
in the,
ఏందంటే ఏ లేయర్ లో యూజ్ చేస్తున్నాం అనేది గుర్తుపెట్టుకోవాలి మనం.
yeah, we need to
నేమింగ్.
remember that. Yeah, just real camera, how the data is transferring. So data identifier will take care of that. Okay, data identifier, either raw data you are sending, all these things. And then payload word counts will be taking care of that. And then error correction codes, it will computing that error correcting codes. And then pixel bytes, how we are sending that pixel bytes, and then it will be computing by the crc. After that, it will append that footer. Okay, after the footer, end of transmission we are sending. This is the transmitting side. Same way, receiver side also we are having, what is that, read headers. Okay, so what are the read data we are having, that read headers we are having, right? So read headers. After that, read headers, we need to know how many data we are transferring from the transmitting side. And also word counts, same thing will be taking care of that. Okay, that is the, so transmission side, lps transmission, and then packet header, footer, word count, crc, virtual channels, data types, and then virtual channel extensions. So all these things we need to take care of that. In the transmission, in the d5 layer we are having packet header and then word count, all these things. And then c5 layer, which is depends upon the number of lanes, how many number of lanes we are using, depends upon that we are transferring the data. So this is the flow. LPS state, start of transmission, header, payload, footer, and then end of transmission LPS. So this is the transmission of data from the transmitting side to receiving side. Are you understood?
Mm.
Hmm.
Yes, sir.
Fine. Same way, so we are sending that different low-level protocols short packet method. So previously we are sending the long packet method, right? So imagine same thing will be sending here, same parcel, but huge parcel, lots of data you are transferring. That lots of data we are transferring means, so we need to control the messages, right? So for the controlling we need to there, and then control we need to have. After that, synchronizing signals we need. Okay, synchronizing signals. After that, what type of event you are doing, okay, that notification we need. Okay, same thing here also we are doing short packet method, how the data will be transmitting CSI2 short packet, how it is works both for D5 layer and then C5 layer. Okay, so D5 layer and C5 layer synchronizing signals are there, and then ECC or CRC we are using, and then different lanes, that is D5 layer and C5 layer we are using. Okay, same thing. Okay, but short packet method only we are transferring. What is the short packet means? Small images. Okay, small fixed size data. So that means controlled data we are transferring, small data we are transferring data. Okay, that is used by the short packet method. Same thing, what are the things we need to remember? Previously I told you that frame start, frame end, line start. Okay, where the line is starting and where the line is ending. Okay, all these things we need to remember. Okay, in the short packet method, where you are starting the frame, where you are ending the frame, so that we need to know about it. Okay, so what are the things we need to know? So LPS, I told you that it is in low power states. After that start of transmission, it is switching from low power states to high transmission data bytes. In the short packet data, we are having 32-bit short packet. In that identifier data is there, data identity is there, and then short packet data, data 0 and data 1 is there. After that, virtual channel extension and ECC. Same thing I have explained in the long packet
Long
format
packet.
also. Yeah, long pattern also same thing. Start of transmission means where you are starting the data, and then in the D5 layer we are using 4 bytes. That means 32-bit data we are using. Okay, that 32-bit data, one is 8-bit data is for data identifier, and then short packets. That means data 0, data 1, and then VCS. All these things. Data identifiers, you know that. What type of packet type? Okay, packet type we are mentioning that data identifier. And then in also we are having virtual channels, two virtual channels are there. Okay, these two virtual channels will taking care of that which camera is sending the data. Okay, and then data values, data types, what are the data types we are using? That data types we are using like frame start, frame end, line start, line end. So all these things we are using, right? That frame start message, it tells you that okay, what type of frame you are sending. And then line ends, that tells you that okay, where you are ending the data. Okay, so that is the short packet data. Frame, how we are sending the data means depends upon the frame number. So where is that frame number we are having, right? So this is the VCC, virtual channels and error detecting codes, the number of packet footers, and then short packet methods we are transferring here. Okay, and then so here it depends on how the data will be controlling means in the short packet data, that is 16 bits we are sending, right? In this 16 bits, what is the data we are sending? Frame number, line number, and then user defined data. That means short generic data types we are sending. Okay, suppose your frame number should be either some 20 frames you are sending. Okay, so 20 frames you are sending, and then different virtual channel extensions are there, and then error correcting codes are also there. That means this packet is belongs to frame 20. Okay, so you are sending 20 frames, then packet is belongs to 20 frames data we are sending. Okay, so that's why the frame number is used. And then line number, so in which line you are sending the data, that is the purpose we are using the line number. Okay, Not only 20 frames, you can also send 200 frames, you can also send 25 frames, you can also send 50 frames. Based on that, we are sending the data. Okay, clear?
Okay, sir.
Hmm. So that is the importance of the frame number and line number, and then end of transmission, and then low power states. You know that. So that is that return to low power states, from high speed data to low power state. Okay, so that is the main thing. And why we go for the synchronization here? So because synchronization means frame start, that is the beginning of your image, and then frame end, that is the end of your frame, and then line start, beginning of the line, and then line end, that is the beginning of the line. Okay, suppose camera, how we are sending the data means which line you are sending the data, so that line we tells about the frame line. Okay, and which byte you are sending the frames, that tells about the frames start. Okay, so that is the things we are sending the data. Similarly, same thing we are talking about the C5 layer. Okay, C5 layer we are having 6n into 16 bits. Okay, similarly, previously is also same, right? 16 and 6n into 16 bits. That n depends that how many physical lanes we are using. Okay, same lane start and then fields are repeating here, right? Synchronization, reliability, lane alignment, all these things we are thinking about it. Okay, see what are the things we are having in the short packet: reserved bits and VCX bits, and then data identifiers. After that, short packet data fields, and then checksum fields. Okay, packet header checksums, all these things. Okay, in this packet checksum header fields, you are detecting 1 bit error or 2 bit error, so or more number of bits error it will be detecting. So 1 bit error you are identifying very easily, but multiple bits means it is unable to identify, right? So that is the complexity will be increased. Okay, so in row 1 you are sending, similarly row 2, similarly row 3, so different data we are sending. Okay, so what is the insert sync? We are using this sync word, insert sync word in the PPI command. So because C5 layer insert sync word, we are using some unique C5 feature. Okay, so that unique C5 feature is used to arrange the data, right? So we are having the data in between, that sync word is there, right? Okay, sync word is used to simultaneously we are sending the data, so that means we are sending the data with synchronizing with the clock or not. Okay, that is the synchronous word we are inserting in the C5 layer, that is not available in the D5 layer, right?
Mm.
Hmm. Okay, so that is the short packet method. Okay, anything else we are missing here? This is the short packet method, ECX reserved bits, and then VCX 2 bits, 3 bits are there. VCX is 3 bits, and VC is the virtual channel extension is the 3 bit, and then virtual channel is the 2 bit. Total 5 bits. That means 32 combinations it will be supporting that. Okay, data identifiers, you know that. So is RGB data, all these things. VC is the 2 bit, so total 5 bits of the virtual channels. And then short packet supports that 16 bits of data, that means 2 bytes of data we are transferring that. Okay, some generic data. And checksum, we are identifying that some no packet error footer, and then no packet filter, or short packet methods purpose we are using. So these are the differences between the D5 layer and C5 layer. Here 32-bit, here depends upon the number of lanes. Yeah, so if lane is 4 lanes you are using means 4 into 6 24, 24 plus 16, total 40 bits we are sending that. Or your lane is some 6 bits of data, so that means 36 plus 16, so total 52 data we are sending that. Okay, depends upon the lanes we are sending. Okay, clear?
Clear.
Any doubt in this slide?
No, sir.
Okay, so data identifiers, you know that, right? So what are the data identifiers are there? So different data identifiers, and then RGB data, YUV data, all these things we are having the data identifiers. Okay, so that means how does your receiver know which stream of data is belongs to which type of data? So that will identify the data identifiers, right? So you need to know who is sending, who is receiving. So that will be taken care by the data identifier. Okay.
Okay.
So that means thousands of data you are transferring, in which data we are sending the data, for which byte you are sending, which frame we are sending, that you need to identify by using data identifiers. Okay. So this ID data identifier is a 8-bit data. Okay. So this 8-bit data we are having, 6 bits are used for data identifiers and 2 bits are
Okay.
used for virtual channels. So this virtual channel, I told you, right? What is the use of virtual channel? Virtual channels for which cameras are supported by the, that means, see, multiple
Containment,
lanes.
sir.
uh,
Virtual channel.
uh, Virtual channels, what is the purpose we are using virtual channels? Which camera you are receiving the data, front camera or rear camera, or some sensors. Okay. What is the transmitter you are sending the data, that will tells you the virtual channel, right? Okay.
Okay.
Understood. So which camera you are sending the information and then you are receiving the information, that will tells by the virtual channel. So I told you that virtual channel is that 2 bit, right? VC0, VC1,
One.
VC2, VC3. Okay, so 4 combinations are possible. That means 00, 01,
Zero, one, one,
10,
one,
11, 11 combinations are there. So 4 virtual channels are used, and some also extensions are also we are using. See, this virtual channel 0 is used for some front camera, this is used for rear camera, and this is used for depth sensors, and this is used for IR sensors. Okay. So for that purpose we are using these 4 virtual channels. And
Okay.
also here two that is 2-bit virtual channels, and then these are most significant bits. That means data 7 and data 6 are the most significant bits, right? So
MFB bits.
uh, so here receiver quickly extracts which stream of data you are sending. That is the ID purpose we are using that. Okay. So which department, see, you are working somewhere, and which department you are working side, DV side or PD side or PV side. Okay. So in which department you need to work, that we need to know. That will tell us about the identification. Okay. What are the data types? Okay. What does data types tells you? Okay. That means you are sending what type of data payload you are sending. Okay. That will tells you that data types. Okay. What type of payload you are sending? Okay. Either raw data you are sending, or JPEG data you are sending, or YUV data you are sending, or RGB data you are sending. Okay. So where you are starting the frame and then where you are ending the frame. Okay. All these things are explained by these data types, right? So 6 data bytes are there, all are LSB bits. Okay. Least significant bits. Clear this data types? And then
Clear, sir.
what is the use of data types and what type of data types you are having? So different data types we are having, like different data we are 101010 data we are sending, or 01 we are sending. That means virtual channel 1 we are using, and then so this is the specific data type we are sending that. Okay. So that data depends upon the data, which data type, which bytes are sending the valid data or not, it will tells you. Okay. Clear? Any
Clear.
doubt? Fine.
Clear.
Okay. Okay. So next one is virtual channel identifiers. Shall we continue, or we can stop here?
Virtual.
Virtual channels identifiers, I told you that. So
Mm.
virtual channels and cameras identification. See,
Mm.
it is a
Which type
2
of
bit.
camera?
This is a 2-bit least significant bits, and this is a 3-bit, that is the most significant bit. So total are 5 n bits are used. So 4 for D5 channel and 5 for D5 channel. Okay. So these are the data identifiers. In that, virtual channels are 2 bits, and then packet header, last 6 bits are first 6 bits are used for ECC, and then
Error.
last after 3 bits are used for 2 bits are used for D5 layer, and 3 bits are used for C5 layer. Okay, so that is the total. See, total 4 bits in D5 layer, and then total 5 bits in C5 layer. Okay, so that is the VCX channel purpose. So all these things are used for see, you are staying in Bangalore, then you are sending the data, you are transferring the data from Hebbal to Silkboard. Okay, so then different lanes of buses are there. Some 500D is there, 500A is there, and then 500F is there. Okay, so 500L is there. So all these lanes of routes of lanes will be transferring the data from source station to destination station, but these are having different routes. Okay, so based on the route number, which bus is going to which station, we are identifying, right? Okay, same thing, this virtual channel is also having that identifiers. Okay, that identifier will tells you which byte lane is having the which byte lane is having that different data bytes, valid data bytes, and then which byte lanes are invalid data bytes we are sending. Okay, that is the use of identifiers. Okay, so these are the identifier data bytes we are using. Clear?
Hmm.
Hmm. So different virtual locations we are having some 2 bits, and then 3 bits. So that is total 8 bits of data we are having in the D5 header. So what is the D5 header? Data identifiers, word count, and VCX ECC is there. And similarly C5 VCX is there. Okay, that is the things. VCX is the 3 bits for C5 layer, and then 2 bits for
Okay.
D5 layer. Okay, see, VCX is the 2 bits for D5 layer. So total VCX plus VCX is that D5 layer is 4 bits we are using. That means 16 channels, virtual channels we are using. And then in D5 layer, sorry, C5 layer, we are having 5 bits. That means total 32 bits, 32 channels are using, right? So that is the logical channels block diagram we are having. See, channel 0 to channel 2 power n minus 1 depends upon the lanes of using in DeFi layer. So it will ending here. Okay.
Hmm.
Hmm. So same thing, we are receiving the logical channel. We are having different extracting VCS channel. So virtual channel identifiers, and detect that logical channel control. After that, logical channel control, which packet data is sending correctly. Whatever the packet data we are sending correctly, we need to identify that. Okay. So each packet header, and then demultiplexer, interleaved streams. Interleaved, I told you that packet one, after that packet 2, so mixing of data we are transferring. Okay.
Hmm. Hmm.
Hmm. So that is the multiple streams we are having. Okay, so in VC0, and then VC1, VC2, see VC0 virtual channel 0, same LPS state, start packet, packet header. In this, RGB 666 is transferring. That means total 18 bits are transferring. Again, RGB 888 similarly RGB 565, that means 16 bits are transferring. JPG 8 bits are transferring. Okay, JPG format virtual channel. See, virtual channel 0, virtual channel 1, virtual channel 0, virtual channel 1. See, all these VC0, VC1 we are using.
Hmm.
See, alternatively, we are sending the data for RGB, YUV, RGB, RGB, RGB. And similarly, RGB, JPEG, MPEG, all these data we are transferring, right?
Yeah.
Hmm. Then interleaved means, so not physically separatable, right? So interleaved packets means we are sending the packet by packet, but that is not physically separatable. Okay, so complete structure, you know that, right? LPS, SOT, and then packet header, data, packet footer, and F transmission. Okay,
Okay.
so this VCX is the legacy device supports. We are supporting that. Okay. And then D5 layer and C5 layer differences are there here. Any differences in this? No, not there, right?
లేదు.
Hmm. Okay. So this is the interleaving concepts and then data types we are using in the virtual channels and then virtual channel extensions. These are the different data types we are using. Okay, RGB data type, YUV data type. So we will tell you all these channels. See, data types we know that. Okay, all these things we know already. Okay,
Mm. Mm.
so RGB packet and then see YUV data, RGB data, raw data, user defined data. So and then from 00 to 37 we are sending the data. So in between that different data we are transferring there. So short packets we are transferring from first byte of data, and then second byte of data general packets we are transferring, and then third byte of data we are transferring that image is long packet format data types, and then third data we are sending YUV data, RGB data, raw data, and then user defined data. Okay, so all these things are transferring. Okay, so that means you are shipping the box from one transmitter to receiver side. So these different many data types we are using. Okay, clear.
Clear.
Mm. So this is the different data bytes types of classes we have. Same thing. So 0, 1, 2, 3 raw data, all these things. Okay.
Okay. Mm.
Mm. So these are the data types we are using in the
What
what it called virtual
virtual
channels.
channel.
Uh, so YUV data, all these things we are transferring. Mm.
Okay.
Mm. So
సో
then
మనకి
this. Mm.
డెఫినేషన్స్ ఉన్నాయా సార్? ఎందుకంటే ఒకసారి చదువు
Mm.
ఏదైనా పీడిఎఫ్ ఉందా సార్ మనకి డెఫినేషన్స్ కి
Yeah, I
అన్నింటికి?
have shared that.
పీడిఎఫ్ ఏం పంపలేదు నాకు. అది ఓన్లీ ఇమేజెస్ దే పంపారు.
No, spec I have shared with you. Just check that. Okay. So up to this you can study. So I'm stopping here. Packet
ఓకే.
header. So checksum we need to do.
ఇది ఇంకెన్ని డేస్ పడుతుంది సార్ సిఎస్ఐ?
So maximum I will tell you.
24 లో ఉన్నాం మనం.
Oh, okay. Recording is not there. ఎప్పుడు ఆగిపోయింది 11 నిమిషాలకే ఆగిపోయిందా అయ్యా ఓకే సో లెట్స్ సీ స్క్రీన్ ఆగిపోయిందా రమ్య
ఆగిపోయింది సార్.
ఓకే